Hi friends, welcome to Maths 369 YouTube channel. Today we are going to discuss about vector algebra. This is one of the important topics in JEE mains. Vector algebra. So we know that there are two types of physical quantities. There are two categories. Quantities, physical quantities are two categories. That is scalar quantities and vector quantities. Scalar quantities and vector quantities. Two quantities are there. Scalar quantities. A quantities which has only magnitude. A quantity which has only magnitude. That is called scalar quantities. That magnitude is related to any fixed point. Any fixed point or fixed direction in the space. Example, mass, length, volume, density, time, temperature, etc. These are the examples of scalar quantities. Second one is vector quantities. A quantity which has magnitude as well as direction. Magnitude as well as direction, both it is. So that is called a vector quantity. Force. Example for force, velocity, acceleration, displacement, momentum, etc. So these are called vector quantities. Quantities having magnitude and direction but not obeying the vector law. If it is not obeying the vector's law of addition, then will not be treated as a vector. So the quantity it should follow that magnitude and direction, and it gives it satisfies the vector law of addition. Then we can say that it is a vector quantity. Otherwise, it is not vector quantity. So representation of vector. Directed line segment. Directed line segment. Let L be the line. L be the line. A straight line in a plane. The line can given two directions by mean of arrowhead. These are the arrows. A line with one of the other direction is prescribed is called directed line. So this is the directed line. L1 and 2 are the directed lines. So this is the directed, and there are 2 points P and Q. So the directed line segment with initial point P. Here P is initial point. Initial point, and Q is terminal point. And Q is terminal point. So the directed line segment. This is the line segment from segment with distance from P to Q. Length of that 2 points. Distance between the 2 points. That is magnitude and with direction. So here it is moving from P to Q. P to Q. So it is denoted by a PQ vector with arrow bar, or A vector also can write. So it follows three characteristics: length, support and sense. Length, support and sense. What is length? The length PQ is denoted by from distance from point P to point Q. The distance from terminal point, initial point to terminal point is called length. It is called a magnitude denoted by PQ mod. Suppose the line of unterminal length, which is directed to line segment. Sense is from initial point to terminal point, where the point is starting point and from where it is moving. That's so here sense. This is called sense. Vectors are denoted by a bar arrows with arrows. A bold letters of A, B, C, bold letters. Now we'll discuss the types of vectors. A vector whose initial and terminal points are zero vector. Zero vector and null vector. A vector whose initial and terminal points are identical or coincident. That vectors are called zero vectors, denoted by 0. It cannot be assigned a definite direction. It cannot be assigned in a definite direction. Examples is A bar, A vector, B vector, C vector are the zero vectors. Proper vector. Any non-zero vector is called proper vector. Now discuss that unit vector. A vector of a unit magnet is called a unit vector. It is denoted by A cap. A cap is equals to vector A by mod A, magnitude of A. Vector A by vector by modulus or magnitude. It is unit vector. So it is denoted by A cap, whose magnitude is 1 unit. Unit is called unit vector. The vector whose magnitude is unit is called unit vector. Co-initial vectors. Initial, co-initial. Two or more vectors having same initial point is called co-initial vectors. Like OA, OB, OC, OD. O is the initial point. These are the co-initial vectors. Next, co-terminal vectors. Two or more vectors having same terminal point. That is called co-terminal vectors. AP, BP, CP, DP. So P is the terminal point. So AP, BP, C, DP, these are all co-terminal vectors. Next one is collinear vector or parallel vectors. The two vectors A and B are collinear if they have same directions, are parallel or anti-parallel. Magnitudes are different. Example is A vector is equals to lambda B vector. B is scalar. A vector is equals to lambda B vector, and lambda is greater than 0 and lambda B is scalar. Non-collinear vectors. Non-collinear vectors are said to be acting on different directions. It is also called as independent vectors. So here is O, B, this is A vector. Coplanar vectors. If they lie on the same plane, two or more vectors lie on the same plane, and two parallel vectors are coplanar. More than two vectors are coplanar if all the lie in the same plane. That is coplanar vectors. Free vectors. Origin of a vector is not specified. That is called free vector. Whose initial points are not specified. For example, if you take ABC triangle, so this arrow, origin of vector is not specified from this. So that is free vector. Like vector and unlike vectors. Two parallel vectors having same direction is called like vectors. So OA, BC, AB, these are the parallel vectors, also called as like vectors. Two parallel vectors having opposite directions. So AB and CD, these two are the parallel with opposite direction of vectors. Position of a vector. Let P be the O be the origin. Let O be the origin of the vector. P be a point in the space. The position of vector is denoted by OP. OP. O is the initial and P is the terminal point. So then P is OP vector is equal to xi cap plus yj cap plus zk cap. Ij are the unit vectors. So this is xi length, yj, zk length. If A and B are two position vectors of A and B, then AB vector is equals to OB vector minus OA vector. That is position vector of OB minus position vector of OA. AB vector is equals to position vector of OB minus OA. Similarly, PQ is equals to OQ minus OP. OQ minus OP. So the magnitude of OP vector is equals to square root of x square plus y square plus z square under root. It is denoted by R. Next one is negative vector. If A and B are two vectors are said to be negative vectors, they are same magnitude but opposite directions. The two vectors having same magnitude but it has opposite directions. So BA is the negative vector of AB. So BA is equals to minus AB. This is the representation of negative vector. Minus BA also can write that. AB is equals to minus BA. Equality of two vectors. If two vectors are said to be equal, if they have same length, means same magnitude, parallel support, and same sense, same directions, same sense, it satisfies these three conditions, we can say that given vectors are equal vectors, equality of two vectors. Triangle of vector of addition. If two vectors are represented by two adjacent sides, A and B, two adjacent sides, this is A vector, this is the B vector. The closing side of a triangle is taken the opposite sides of the two adjacent sides. It is represented as sum of the first two vectors. Sum of the first two vectors. So this is the closing side of in the triangle. So this closing side is equals to sum of the two adjacent sides, A vector plus B vector. If you draw the triangle, any triangle, this is A, this is B, and this is C. Now here closing side is AC. This is the vector length, this is the B, A. Now AC is equals to A vector plus B vector. This is the closing side. So vector is moving from A to B, then B to C. To close this, by adding A and C, so this side is called closing side. The closing side is equals to sum of the two adjacent sides. So AC is equals to A plus C. So this is triangle law of vector. Parallelogram law of vectors. If A and B are two adjacent sides of a parallelogram, that is OA is equals to A vector, position vector of OA is equals to A, position vector of OB is equals to OB vector is equals to B vector. So this is also B. Then the diagonal OC vector is equals to A vector plus B vector. If you apply the triangle property, OA plus AC is equals to OC. This is the closing side of the two adjacent sides in a triangle. So therefore, OC is equals to A vector plus B vector. So this is also A vector. If you join that B A, so this will become A vector minus B vector. A vector minus B vector. So that is BA is equals to A vector minus B vector. This is parallelogram law. Now we'll see that. So this is 2023 JEE Mains April 15th question. Based on triangle property, ABCD is a quadrilateral if E and F are the midpoints of diagonal AC and BD. E and F are the midpoints of AC and BD respectively, and AB minus BC plus AD vector minus DC vector is equals to K into FP vector. Then what is the value of K? You have four options: 2, minus 2, minus 4, 4. So first find that position vector of E. E is the midpoint of AC. E be the midpoint of AC. Midpoint of AC. So therefore OE vector is equals to A plus C by 2. Similarly, F be the midpoint of BD. So OF is equals to B plus D by 2. Now FE is equals to OE minus OF. By applying triangle property, OE minus OF, that equals to OE is what? Half A plus C minus of B plus D vectors. So if you take half common, what you get? A plus C minus B minus D vector, and consider as equation number 1. Now what is our problem? Question is AB minus vector AB minus BC plus vector AD minus DC is equals to K into FE. K into FE. So AB vector, the position vector of AB is OB minus OA. BC is OC minus OB plus OD minus OA vector minus of OC minus OD vector is equals to K into FE. So this is B vector minus A vector minus C vector plus B vector plus D vector minus A vector minus c vector plus d vector, that equals to k into fe vector. Fe vector. I'll make the group minus a minus c plus b plus d, minus a minus b. So which segmented group is minus a minus b plus b plus d is one group. Next remaining is plus of minus a minus c plus b plus d is equals to k into f vector. So from the equation number 1, 2fe is equals to a vector plus c vector minus b vector minus d vector. If you take minus common here, b vector plus d vector, if you take minus common, a plus c minus b minus d, here also minus common, a plus c minus b minus d, that equals to k fe. So this can be written as 2fe minus 2fe, that equals to minus 4fe is equals to kfe. So therefore k is equals to minus 4. K is equals to minus 4. By comparing that LHS and RHS, the value of k is minus 4. So our option is, third option is correct. K is equals to minus 4. For more updates, like and subscribe Maths 369 YouTube channel.